In this video, we're going to discuss data types that's interpreted via the computer and how that affects the results that the computer gives. Now, we're also going to be focused on this different types of data when it comes to the analysis, because the analysis that we can run on different types of data, which we'll start discussing in week 2, is dependent on the type of data. So the type of data as interpreted by the computer mirrors pretty closely what we're going to be looking at from an analytical side, but we do need to understand very clearly, and again this goes into understanding the problem, we need to understand what the computer is actually doing, what it understands, how it reads these different values, so we can actually tell it this is what we want. The data types that we're going to focus on from a computer standpoint, on the left here you see the basic data types. The computer, there are a few more data types than just these, but I'm going to focus on these three as I think they refer to them as atomic data types. There's numeric, logical, and character. Now, numeric is what you'd exactly expect. It's numbers. And the way the computer can store them is either as integers or doubles. Doubles are values with floating points with decimals. Most of the time, most of the work that we do, we're going to be dealing with the doubles. You can save a little memory if you know you're working with integers, and sometimes that might be helpful. But for this class, we're going to just say numeric, doubles. That's what we're going to use for our standard in any numbers that are meaningful to us. Logical is very simple. Boolean, you might have heard it referred to as before. True or false, yes or no. We're focusing with simply two options, and very specifically, the way the computer interprets logical types of data is exactly true or false. That's it. There are no other options other than missing. Characters are anything with text. Text can be words, it can be letters, it could be numbers that the computer reads as letters. And you might say, well, that seems kind of odd, but the computer doesn't really know any better. It interprets numbers in a very strict way. If you put a number in quotes, put a string of text in quotes, it interprets that as a character or a string, and it can only do certain things with strings. There's some things you can do with strings you can't do with numbers. There are some things you can do with numbers you can't do with strings or characters. So we need to be very clear on what the type of the data is. There is actually a function in R called type, I think it's called type of, and you ask for the variable, it'll tell you what the computer thinks the type is. Now you could say, well, all right, those are the atomic data types, the basic data building blocks for values, variables, numbers, what have you. But what if I have a list of them or a series of them? How do I store it? How do I store that data? Vectors are our primary focus, and we'll talk more about this in the next video. The vectors are kind of the building block of R. R is focused on vectors, in which is a list or a sequence of numbers that are all the same type. I should have said a sequence of values that are all the same type. They could be a list of names, could be a list of numbers, could be a big long list of trues and falses. As long as everything in it is the same atomic data type, we can put that into a collection known as a vector. A matrix is very similar to a vector. Again, the values in it must be of the same data type, but this one is two-dimensional. In other words, I can have a row and a row-column application for each value. Factors are how R stores items with discrete categories. In other words, I might say, you know, these values are, how do I rate this restaurant? Poor, fair, good, excellent. Those are specific values. They are strings, they are characters, but I'm only going to allow you to pick one of those four options: poor, fair, good, or excellent. If those are the only four values you can pick, a lot of times R would like to refer to those as factors, because it says, look, there's only discrete options that you can choose. We'll talk more about that in a few videos. Lists are similar to vectors, but this time they let me store a list of values that could potentially be different types. So now I could say I have a name, a social security number, an age, a weight, all associated in one list. So I have a person's name, social security number, height, weight, GPA, so forth, all in one specific list. Some are numbers, some are characters, could have some logicals as well. Finally, the most common one that we will probably use the most other than vectors would be the data frame. And the data frame is kind of the standard table that you imagine in data analysis. Basically, each column denotes a variable, and each row denotes an observation. So now I can have a big, suppose the members of our class. We can have a data frame that stores information about all those members. In column 1, we're going to store everyone's name. So those would all be character values. In column 2, we can store everyone's height. That's a numeric value. In column 3, we can store everyone's weight. Again, a numeric value. Column 4, we can store, do you have a business degree from an undergrad? That's a logical, true or false. The data frame is probably our most friendly way to store data as a data set that we are going to be using throughout the entirety of this class. Understanding all the different values are very important because a data frame might contain elements that are character or logical. A list can help us bring together some factor information with other vectors. Because remember, a list can contain different values. That could be, a list could contain lists. A list could contain vectors. It could contain one vector, one list, one character value, and one numeric value. There's lots of different ways these combine. We're going to spend most of our time focusing on vectors, factors, and data frames.